Hello everyone. In this video I'm going to be giving a short introduction to Arduino. As many of you know, Arduino is an open source electronics platform made for tinkerers, hobbyists, students, or really anybody interested in creating their own electronics projects. For me, Arduino is the go-to option for any embedded systems projects, and it is a great tool for learning electronics and how to code. The first step is to choose the Arduino board that you want to use. Depending on the needs of your project, there are several different options to choose from. Arduino boards come in many different shapes and sizes with different amounts of RAM, processing power, I/O, different ports, and power delivery options. So you just need to do some research and find the board that you think will work best for your application. I should also point out that since Arduino is an open source platform, there are several different companies that manufacture and sell Arduino compatible boards. The board that I will be using in this video is one of the more powerful options, which is the Mega R3 board from Elegoo. You can also buy this board directly from Arduino themselves, but the Elegoo Mega R3 board is currently $21 on Amazon, while the same board from the Arduino company is more than twice that price at over $48 on Amazon. Once you've picked out the Arduino board that you want to use, you'll need to download the Arduino Integrated Development Environment, or Arduino IDE. And to do that, you'll head over to arduino.cc, click Software, and then download the version for your system. In my case, I am running Windows 10, so I will click the Windows 10 option and download it. And then I'll go ahead and cancel this because I already have it downloaded, but for you, you would finish this download and install the Arduino IDE software. Once you have the Arduino IDE downloaded and installed, you're going to go ahead and plug your Arduino board into your system and open the Arduino IDE software. And once that is open, we're going to head over to Tools and go down to Board and select the board we're using from this drop-down menu, as well as the processor on that board and the port that that board is connected to. A lot of the time, these options will fill themselves out automatically, but this is where they are in case they do not. This window is where you will write the program that you want to run on your Arduino. In this setup section, you will put code that you only want to run once on startup, and in this loop section, you will put your main program code. Also, if you come up here to File and then Examples, you'll see a bunch of built-in examples that you can explore. I will go to Basics Blink, and this is an example program that just blinks the built-in LED on the board. If you come up here, you will see two buttons, Verify and Upload. The Verify button essentially compiles the code, and down here you will see any errors in compiling the code, but of course there's no errors because this is a example program. And then this button sends that, well, it compiles it again and then sends that program to your board. And I just sent it to my board, and I can see the built-in LED is blinking. Here you will see a very simple program that I wrote to show you another very useful feature of the Arduino IDE, which is the serial monitor. So with this statement, I set up serial communication between my PC and the Arduino board, and if we go ahead and compile it, you'll see there is an error because I misspelled input here, so I'm going to go ahead and fix that. Try to compile it again. This time there are no errors, and then I will go ahead and upload the program to my Arduino board. Once that's done, I'm going to go ahead and open Tools and go to Serial Monitor, and in this window you'll see the baud rate that I set was 115200, so I go ahead and select that same baud rate for the monitor, and I can send data to the Arduino. In this case I said hello, and you'll see serial input received, you said hello. The serial monitor is very useful for debugging programs because once you send the program to the Arduino, it can be difficult to tell what exactly is going on, and you can include serial communication so that you have a better idea of what is going on with your program. Very useful for debugging. For the next example that I wanted to show you, I have connected a ultrasonic distance sensor, specifically the HC-SR04, to the Arduino as shown here, with the power pins connected as well as the trigger and echo pins connected to digital data pins on the Arduino. Before we get into the next example program, I wanted to show you another very useful feature of the Arduino IDE software, which are libraries. So if we come up here to Tools and then Manage Libraries, that will pull up a window where you can download and install any number of different libraries that can help you in writing your Arduino programs. In this case, since I'm using an HCSR04 sensor, I'll go ahead and search that and find a library that I think will work for my program. And here we have the one that I downloaded and installed already. But if you wanted to install one, you would select your version and then click install. And you can also click more info, and that will take you to a page that gives you all the documentation and examples on how to use that library. And since we are using this library, there is an include statement so that the Arduino IDE knows that we want to use this library for this program. So, in the main loop for this program, there is a 500 millisecond delay followed by a command that measures the distance in centimeters on the ultrasonic sensor and sends that measurement back to my computer via serial. So if we go ahead and upload this program to the Arduino and open the serial monitor, you will see those distance measurements, and as I move the sensor closer to a surface, they decrease, and as I pull the sensor farther away, they increase. Now I'm going to go ahead and close this and modify this program a little bit to a 50 millisecond delay, so we have a lot more measurements every second. Go ahead and compile that. No errors. We'll send that to the Arduino and open the last useful tool that I wanted to show you today, which is the serial plotter. So if we open that, it automatically plots each distance measurement taken from that sensor. So as I move it closer to a surface, you will see those distance measurements decrease, and I can pull it farther back from a surface, and those distance measurements increase. Arduino really is a great way to learn about electronics and programming. I hope you found this video helpful, and please feel free to leave any questions in the comments down below.